Bonus points for anyone that doesn't have to use their phone to tell me what song that was. Maybe even getting the band. The band's probably the easier one, but bonus points if anyone can tell me who and what song that was. Anyways, continuing with our last unit, we are now moving to instantaneous rates of change, which will be the focus from now on. From now on, it will also be known as IROC. Our learning goals, we're going to calculate and interpret the IROC at a given value of the independent variable. So I'm going to let you look at that little moving image for a second. So last lesson we did AROC, average rates of change between 2 points. And yes, that's useful, but it becomes less useful when we talk about curves because they're always changing. And it's much more useful in like physics, for example, and obviously calculus and vectors, just the calculus part of it, to determine the rate of change at a particular value. So at x equals a, let's say. And this is the slope of a tangent at that point. So it can be estimated using AROC or secants for small intervals that are close to the value. So if you take a look at that moving image, there's one point that is moving and it's getting slowly closer and closer and closer. And you can find the rate of change of all of those linear lines. And the closer you get to that point, though, that's static, x equals a, the better the approximation to what the rate of change is at that specific moment. Now, this happens to be approaching from the right-hand side. You could also approach from the left. You could also approach from both sides and meet in the middle. So we're kind of, doing something kind of tricky here. Or, kind of like a Houdini act. It's a magical act. We're taking something that's curved, but still using straight lines to help us calculate a value. And the reason is we can get so close that even if you looked at it under like a microscope on like a 300 times zoom, you could still get so very close that you're almost on top of the point, but you're not exactly on it, but you're super close. And since that interval is so small, even though we know in our hearts that it's curved, that interval is so small and so magnified, it looks like it's linear. Our first example, we are going to estimate the IROC, instantaneous rate of change, for f of x equals x squared plus 2 when x equals 4, so a very specific value. And we're going to use what's called the preceding interval method. It might help us to make a quick sketch, so I'm going to make a quick sketch here. X squared plus 2, that's just something that's a parabola opening up. That has been moved up 2. X equals 4. Let's just say that x equals 4 is right there. That's like my a value. I want to know what the instantaneous rate of change is at that point. Preceding means before. So we're going to approach it coming around that way and getting smaller and smaller and smaller. We already know that it should be positive, right, based off of that, which side of the parabola it's on. We're going to look at 3 different methods. I'm never going to force you to do any of these 3 on your test. It's not going to say do preceding, following, or centered. It's going to just say use one of those interval methods using a series of IROC calculations, and then you can pick your poison. This is just calculator work. That's all it is. So what you pick here really is up to you. However, I at minimum need to see these 4 intervals I'm about to do. So if we're approaching from the left, basically it means we're doing, so we know that our interval is going to be between a minus h and a. And that h is that little interval that we get closer and closer and closer to. So we're going to do a is 4 in this case. So I'll write a equals 4. And we're going to subtract a little bit away from that. So let's start with between 3 and 4. And we're going to do a series of IROC calculations, right? A series of secant lines. But the secant line is going to get so close to it eventually, it's going to kind of look like a tangent line, only touches it once. So what's that? F of 4. And again, I'm only going to write the formula for this first one. And then after that, it's up to you. So f of 4 minus f of 3 all over 4 minus 3. Putting that into your function, you should get 18 minus 11. Obviously, 4 minus 3 is 1. That equals 7. And again, there's no units attached to that. Now let's get a little bit closer. So again, we're approaching from the left. So maybe let's do between 3.5 and 4. And IROC equals f of 4 minus f of 3.5 all over 4 minus 3.5. Put those numbers into your calculator. I'm going to cut to the chase here. Keeping in mind, you should never round until you get to the very end of the question. So I'm going to challenge you to kind of keep all those decimal places in your calculator without clearing it, work through the bedmiss, order of operations to get to your final answer, and then round at the very end. So if we round at the very end, you should get 7.5. Okay, let's try another interval. Again, we're getting closer and closer to 4, approaching from the left. So let's go to 3.9 is less than x is less than 4. Again, we're doing IROC, so IROC equals f of 4 minus f of 3.9 all over 4 minus 3.9. That is just calculator work. Round at the very end, you should get 7.9 approximately. And then we're going to do it a 4th time, and then we're going to start to notice a pattern here. So let's get a little bit closer to 4. Let's do 3.99 and 4. IROC equals f of 4 minus f of 3.99 all over 4 minus 3.99. Calculator work should get 7.99. That is the bare minimum 4 I should see on your test if you're doing an interval method, which I will force you to do at least once. And then in a future lesson, we're going to look at different ways to do this. Yes, you can pick any range or any interval of numbers. I want to see it being like 1 less, half less, a 10th less, and then a 100th less. And then on your calculator, you can prove it to yourself. You don't have to show me the work. You could go to 3.999 and 4, and you'll probably get 7.999. At this point, we're going to be making an estimation. So what does it look like it's getting really, really close to? It looks like it's getting close to 8. So therefore, the IROC of f of 4 equals, and actually I'm not even going to write equals, I'm going to change that. Don't write that down. We're going to write is approximately, because we are kind of doing an approximation, right? is approximately 8. And that's all I need to see for this type of question. So the rate of change is positive, should be at the built-in self-check looking at our graph, and it's going to get closer and closer to 8. We're going to do this 3 different ways for the exact same function. So we know we should be getting 8 regardless. We've got to prove it to ourselves. Now we're going to do the following interval method. So again, make our quick little sketch. Parabola opening up, moved up 2. We still want to know, so there's 4. But instead of doing the preceding, we're doing the following, meaning we're approaching from this direction, something bigger than 4. So we're doing something like this, where a is less than or equal to x is less than or equal to a plus h. So 4 plus some small little number, h. Just like last time, we'll stick with 1, the difference being 1 for our first interval, so between 4 and 5. IROC equals f of 5 minus f of 4 all over 5 minus 4. You do all the work on your calculator, you should get 9. Now we're going to get a little bit closer. So 4 and 4.5. And again, IROC equals f of 4.5 minus f of 4 all over 4.5 minus 4. Calculator work should get 8.5. And already we see the writing on the wall like we know we should. We should be getting 8, and we are definitely getting something that seems to be getting closer to 8. Let's get a little bit closer, 4 and 4.1. IROC equals f of 4.1 minus f of 4 all over 4.1 minus 4. And we should get 8.1. Now before doing the fourth one, I just want to point out to you, if you're thinking like this is tedious, you are right. And we are going to be moving into something later in a future lesson that will make it a little bit less tedious. This is just calculator work. Do you have to show all of your steps? Well, the answer for your virtual test is kind of yeah, but even more so for this, if you only write what I just write right here and you make a mistake, I have nowhere to know where you made a mistake. Whereas if I can see the numbers you typed into your calculator and what you got, I can be like, oh, I can see exactly where they made a mistake. Very minor, 3.5 out of 4, let's say. If you just show what I'm showing here, but explaining to you obviously, but if you just show this and you make a calculator error, I can't give you that same benefit of the doubt. I don't know. So you wouldn't maybe get 3.5 out of 4. Maybe you would get 3 out of 4, 2.5 out of 4, 2 out of 4. Who knows? Just keep that in mind when you're doing these. And then we're going to do it a fourth time. We have to do it a minimum of 4. So we're going to get even closer. So say 4.01. So 4.01, IROC equals f of 4.01 minus f of 4 all over 4.01 minus 4. 8.01. And if you did it a fifth time and you went to the thousandths, so 4.001, it should be 8.001. So we can again make the estimation that the IROC, based off of the pattern we're seeing with our IROCs, is getting close to 8. So therefore, the IROC of f of 4 is approximately 8. The third and final way I will show you how to do this, the centered interval method, meaning you are going to approach it from both sides, equal distance away from that a value. So equal distance away from 4. I'll make a little sketch to start. Parabola opening up, shift it up to, and there's 4. So I'm going to approach from equal distances from the left and the right so that 4 always ends up exactly dead smack in the middle. So this looks like a minus h, so 4 minus some little number, and 4 plus that exact same little number. So it ends up perfectly smack dab in the middle. So 3 is less than or equal to x is less than or equal to 5. 4 is obviously right in the middle of that, right? 4 is in the middle of 3 and 5. IROC equals, back to all this fun calculator work, should get 8. Let's get a little bit closer to 4 from each side. 3.5 and 4.5. Again, 4 is definitely in the middle of those two numbers, in the center. IROC equals f of 4.5 minus f of 3.5 all over 4.5 minus 3.5. And we get 8 again. This is good. Get a little bit closer yet. Between 3.9 and 4.1. 4 again is perfectly in the middle. IROC equals f of 4.1 minus f of 3.9 all over 4.1 minus 3.9. What do we get using our calculator? Whoa, big surprise, 8 again. Finally, we got to do it a 4th time. We'll go between 3.99 and 4.01. Again, 4 is right in the middle. So IROC equals f of 4.01 minus f of 3.99 all over 4.01 minus 3.99. What do we get? 8. Again, therefore, IROC of f of 4 is approximately 8. Hopefully that makes sense. We did it enough where you get the idea. Our second example, and actually our last example, we're going to do a word problem. The value of a home in thousands can be approximated by this exponential equation. So V of t equals 150, 1.04 to the t. T is the year since 2000. Estimate how much the value of the house will be increasing in the year 2020. And I'm telling you to use the centered interval method. You could use any of them. I'm just telling you to use the centered one. All right. So we need 20 to be in the middle. So let's do 19 and 21. Excuse me. So we're going to do IROC equals V of 21 minus V of 19 all over 21 minus 19. And we're going to go to 2 decimal places, let's say. So we should get 12.89. Now this has units attached to it, and since it says it's in thousands, this is actually 12.89 thousands per year. Let's do it between 19.5 and 20.5. Again, 20 definitely in the middle. IROC equals f of 20.5 minus f of 19.5 over 20.5 minus 19.5. Using your calculators, we get 12.89, and I'm just going to write instead the number of thousands per year. That's good that we got the same thing. We still have to do it 2 more times though. That's the bare minimum. So let's do 19.9 is less than or equal to t is less than or equal to 20.1. IROC equals f of 20.1 minus f of 19.9 all over that. Rounded to decimal places, we get 12.89 again. And that again would be thousands of dollars per year. Gotta do it a 4th time. 19.99 and 20.01. IROC equals f of that minus f of 19.99 all over b minus a. And spoiler alert, we get 12.89 thousandths per year. Now I should point out, because this was in thousands, and because money is usually rounded to 2 decimal places but at the very end, you would have actually got different numbers if I had you round to 5 decimal places. So you would have actually seen that change, getting closer to the nearest dollar and nearest penny, if I had you round to 5 decimal places. But I didn't, just to kind of simplify it a little bit for us. So to answer, our question, therefore, the value of the house, now we got positive value, so it means it's increasing, is increasing by approximately $12,890 per year. Just putting it back, $12,890 per year. And if you went 5 decimal places, you actually would have had that down to the penny accurate, which I think it would have been $12,890.61, I think. Maybe you remember seeing that kind of 0.61 at the very end. Again, that is it. The rest of our lessons are about IROCs. There's your work, plus I've already started assigning some review work for your test. Thanks for listening. Talk soon.